Hello and welcome to 7 Days of Shark Science. Coming up in the news this week, I say olive oil for olive oil, Ben shows us all what he wore at graduation.
Thanks, Doug.
And I run at a man with glasses. As well, in the roles of directors, producers and... There's a little personal announcement at the end of this video, so do wait around for that if you're interested. Starting off this year's 7 Days of Shark Science, a study published in the Journal of American Chemical Society has determined the chemical structure of boron monoxide, around 8 decades since its discovery. Boron monoxide, as the name suggests, is a binary compound containing boron and oxygen. First reported in existence in the 1940s, the technology of the time was unable to find the specific structure of this material, but modern scientists working on trying to construct a covalent organic framework without using carbon came across this old data and were able to use modern equipment to unravel the old mystery. One of the previously proposed models actually correlated very well to this researcher's concluded structure. As the paper states, there has recently been an increased interest in boron structures, and this paper will go far in both stoking that interest and helping us understand boron-based materials further. In other news, a study presented at the Nutrition 2023 meeting in the US has suggested that a regular consumption of olive oil reduces the risk of fatal dementia. The study used a data group of nearly 100,000 people, and their results showed a 28% lower risk of dying of dementia to those who had had more than half a tablespoon of olive oil per day over the period. One of the researchers said that this could be evidence for some antioxidant compounds in olive oil crossing the blood-brain barrier and having an effect on the brain. It was also suggested that the effect could be more indirect, perhaps having a positive effect on the heart, which then affected the brain. Another interesting study on how much our diets can affect our health. Also in the news, a group of orcas off the coast of Iceland have been spotted swimming with a white-beaked dolphin calf. This is not the first time that orcas in this area have been seen caring for an infant of a different species. A few weeks ago, a group of orcas was spotted with a pilot whale calf. And that was not the first time. The behaviour was first documented a couple of years ago. If you would like to know more about this, One World has produced a video on it. A link to the video is in the sources list in the description. And of course, this is 7 Days of Shark Science, so here's the shark news. A study published this week has found that basking sharks, the giant filter feeders, are actually partially warm-blooded. It has always been assumed that these sharks had been fully ectothermic, or cold-blooded, having a body temperature not significantly raised above the environment's temperature. However, after performing dissections of a few basking sharks that had washed up on UK and Irish beaches, scientists discovered some interesting adaptations for regional endothermy, a condition in which certain parts of the body are maintained at a higher temperature than the environment. These include red muscles centralised deep within the body and thick-walled muscular hearts, adaptations first seen in fast-swimming predatory fish species such as white sharks and tuna, but not expected in a relatively slow-swimming filter feeder. The scientists also logged live individuals and recorded their body temperatures, discovering that their white muscle just below the skin was consistently at a raised temperature compared to the environment. So it turns out that basking sharks are probably regional endotherms. A completely unexpected discovery that has surprised scientists and shows how much we still have to learn about these incredible fish. And now over to Ben, who was looking pretty good after his attempts to turn into a shark earlier this week.
Thanks, Doug. Now, before we get into the fish news, I first have to inform you about a couple of new dinosaur species named this week. Boring, I know. Firstly, we have a new titanosaurian ceratopsian dinosaur named from Montana. Coming from the late Cretaceous, the specimen this new species is based on, named as Fucatoceratops elucidans, is an almost complete skeleton with most of the skull present. The brow horns of Fucatoceratops are quite interesting and unique compared to other ceratopsian dinosaurs, being strongly deflected forwards and also curving slightly inwards towards one another. It's found to be a close relative of Nasutoceratops, and the individual fossil itself is thought to represent a subadult, allowing the paleontologists to learn more about the life history of ceratopsian dinosaurs. The fact that the skull bones of this specimen are well preserved but also disarticulated is also actually very useful for the study of ceratopsians, as the individual bones can be used in future comparisons between species. So, a brilliant discovery of a unique new dinosaur. Also in the dinosaur news is the naming and description of a new kind of titanosaur sauropod from the late Cretaceous of Egypt. Called Igai Semku, it's known from various limb bones and 5 vertebrae, and actually tells us a lot about the evolution of sauropods in Africa. It turns out that Igai is quite closely related to other titanosaurs from northern Africa and Eurasia, whereas it's more distant to sauropods further south in Africa, such as faunas recovered from Tanzania. This seems to further support ideas that there was a north-south paleobiogeographic divide across Africa during the late Cretaceous, with northern African sauropods being more similar to Eurasian forms. It's still an unresolved idea that needs investigating though, but it's a very interesting one, and the discovery of Igai adds a lot of new data. Now up next in the news we have a very special interview with paleontologist Sam Cooper on his new paper about a pachycormid fish that seems to have been killed by swallowing an ammonite. Now when I was visiting Germany back in May as part of a university trip, I actually met up with Sam and he very kindly offered to show us this fossil and to do an interview about the paper, which at the time had not been released, but now it's been published. And so he took us behind the scenes at the Stuttgart Natural History Museum and showed us the fossil itself, and very kindly did this interview with us. So here is Sam Cooper talking about this amazing new fossil. Okay, so I'm here with Sam Cooper, who's a specialist on pachycormid fish, and who's going to tell us a bit about this amazing new specimen that's just been published.
Yeah, so what you're looking at here is a really, really remarkable specimen of a fish we call Pachycormus macropterus. It's a fish that's been known all the way back since the 1700s. Very, very abundant throughout the upper Lias of Europe. It's found in Whitby in the UK, and quite recent as well in Strawberry Bank. This particular specimen is from a place we called Holzmarden, which is in southwestern Germany. It's from a formation called the Posidonian Schiefer. And when you first look at the fish, you think, well, there's quite a lot of this specimen, or there's lots of these individuals of this species. But what's interesting about this one is not the skeletal anatomy, but rather what's preserved inside the stomach. So you can see here, this one actually preserves a large ammonite inside of the gut. And we know it's inside the gut for several reasons, mostly because we can see that actually there are some ribs of the fish which are both overlying the shell and are underlying the shell. And also when we look with a UV lamp, there is actually impressions of the skin. We can see the scales here. And these are overlying the entire specimen, so overlying both the shell and the bones of the fish. Yeah. So we know it's definitely inside the gut. And this is quite remarkable for several reasons. One, because it preserves, almost locked in time, this unique predator-prey association. Yeah. And most of the time, Pachycormus, when we do find stomach contents, only preserve soft squids, things like vampiropod squids, belemnoids, not belemnites, but belemnoids. These are ones without a rostra, but they have the chitinous hooks, which often form accumulations in the gut. So where do we want to begin?
So what do you think kind of happened here? What led to this ammonite kind of finding its way inside the fish?
So, as I said, this is a very unusual association, and we've never seen another one like this. What we do know, however, is that the apticae, these are the jaw elements of the soft body animal inside the shell, is not preserved at all. Right. They're missing. So normally we would expect to see them here around the body chamber. Yeah. But they're missing, they're dislodged. So we think maybe the shell was empty at the time of ingestion. Perhaps it was floating around in the water column, and the fish saw it, perhaps thought, oh, that looks like a little squid or a fish in distress, and snap, and perhaps regretted it, but I suppose we'll get onto that point in a second. But what's really remarkable about this specimen is not just the association, but it's the preservation of the ammonites themselves. So, as you've now seen in Dottenhausen, there are thousands and thousands of ammonites that you can find in this formation. They're everywhere, absolutely cover some of the bedding plates. But their preservation is unusual because we only normally find the external inorganic layer, what we call the periostracum. So when you see ammonites in the formation, you only see them as this like very brown, murky film. Sometimes it's semi-transparent, and we can see some of the associated matrix here. It's just a brown. It's just sort of like a brown impression, right? But this one is unique, and I should say the reason this happens is because of chemical dissolution. This is because the mud was very acidic, and so all the original aragonite has dissolved away, leaving only this thin inorganic peristracum. And that seems to be every single ammonite in the formation except this single specimen here. So you can probably see here, this is all this white creamy colour. This is actually the original aragonite shell, which is very, very unusual. And even when you tilt the light, you can see some areas of iridescence. Sort of a shiny mother-of-pearl-like appearance. And this is what we call the nacre. This is the very thin organic layer we see sometimes on the externa of the aragonite. This is what gives that nice shiny appearance in life, a bit like a modern nautilus shell. And so when I first come across this specimen, it's actually been sitting in the drawer since 1977. No one's looked at it, which surprised me a lot since it's got its unusual association. And I thought, well, first of all, maybe it's just a chance association. But then when I looked closer and we realised, okay, it's actually inside the animal, inside the stomach of the animal, we started to think, well, okay, so why is this preserved this way? And the hypothesis we've proposed is that maybe the stomach acted as a microenvironment for exceptional preservation of the mineralogy of the shell. So in this case, the shell being inside the fish's stomach as it entered the mud protected it from external dissolution. So almost like a vacuum seal protecting the original shell material. And like I said, we have not seen it anywhere else in the Posidonian Schiefer. So it's so even though the actual predator-prey association is perhaps the most interesting part for some, for me personally, it's the preservation of the ammonite.
All sorts of things that make this a one-of-a-kind fossil.
Yes.
And so you think the ammonite was the cause of death of this fish as well?
Yes, we do. And we think that for a couple of reasons. So firstly, because when we look at the actual preservation of the shell, it doesn't look very pretty. That's because it's been prepared a bit rough and there's been some issues with how it's been prepared, like there's a part of it that's broken off. This is due to how it's been extracted from a quarry and prepared. But for the areas that are nicely preserved, when we actually look very closely at the aragonite under a microscope, we found evidence of what we call acid etching. And so this is when you find little cross-hatching indentations, sometimes little pits. And this is early signs that stomach acid has started to react and break down the aragonite, also being a calcitic structure. It does not do well with acid. And so we realised, okay, so we know it's in the stomach, we know it was ingested by the fish when it was alive, and so forth. Okay, but if it had been in there for a prolonged period, we would expect the shell to be broken down quite significantly, almost entirely. Modern tuners, which pachycormids quite often use as a modern, compared to as a modern analogue, they typically can completely digest a meal in as little as 12 hours. So I thought, okay, this is a very, very short window we're dealing with. And so we thought, okay, so there's the only scenario where this works, where we have the association and the preservation quality of the ammonite, is one where the fish died almost instantaneously or immediately after it had swallowed the shell. And so from this we hypothesised that, okay, perhaps the shell was actually responsible for the fish's death. So we proposed two hypotheses in the paper. One is that perhaps the shell became stuck in the throat, choked the fish, it drowned and was preserved like this. And then it shifted due to being compacted, because we know that it was sort of laying in a weird angle where it was laying on its belly, slightly tilted to one side, and then it's compacted and pushed the ammonite this way. Or the second hypothesis is that maybe the shell did somehow make it down the throat of the fish, perhaps with the motion of peristalsis, entered the stomach, but then perhaps it blocked the stomach wall, blocked the actual abdominal opening, and perhaps even pierced the stomach wall, resulting in perhaps internal bleeding as a cause of death. But regardless, we know that this ingestion event happened almost immediately before the animal died. And that's the only way that you would preserve this association.
It's amazing you have all these lines of evidence that kind of show the sequence of events here. And what a horrible way to go, but
yes,
it's led to a fantastic fossil. So
well, it's the equivalent if you were to swallow a dinner plate, I suppose.
Would be quite painful, I imagine.
Yes, I don't think it had a pleasant last few minutes to hours of life, this fish.
No.
But we have a nice fossil to get out of it. So.
Well, congratulations on the paper,
and
thank you for allowing us to interview you.
Very welcome.
And what an amazing fossil. I hope you enjoyed learning about this incredible fish and ammonite.
Thank you for having me.
Thank
Cheers.
you. A big thank you again to Sam for letting us interview him about this amazing new fossil. Sam has also had another fossil fish paper published very recently too, this time reporting on a gar from the Upper Cretaceous of Morocco. It's named as a new genus and species, Grandimarinus gerizensis, and is important for being the first complete gar fossil reported from a fully marine Cretaceous environment. Gars today are largely inhabitants of freshwater and brackish environments, though a few do venture out into saltier waters, but they are known to have descended from fully marine ancestors during the Mesozoic. After originating in the late Jurassic, these fully marine gars then seem to have invaded freshwater systems in the early Cretaceous, so the discovery of the late Cretaceous fully marine Grandimarinus seems to represent a late surviving example of this older marine lineage. The paper discusses all of this and details the anatomy of this incredibly complete specimen, as well as looking at how it was preserved. So some fantastic fish news this week, and I really hope you've enjoyed learning about all these amazing discoveries that have been made in science in these last 7 days. Back to Doug in the studio.
Thank you, Ben. Just a quick announcement from me. I'm going up to the Edinburgh Fringe Festival in August with an incredibly talented team to put on Dennis Kelly's DNA. Some of those involved in the short film that Ben and I have been working on are working on different aspects of the show as well, in the roles of directors, producers and cast. It's going to be great, so if you're going to the Fringe at that time, come and support us. I'll put the link to the tickets and the trailer for the performance in the description below. That's it for this year's 7 Days of Shark Science. I do hope you enjoy, and we'll see you tomorrow for more Shark Week.